In this video, we are going to look at how are electrons arranged. In the periodic table, the elements are arranged in order of increasing proton number. That it means that hydrogen atom equal 1, helium 2, lithium 3, beryllium 4, boron 5, and so on. The distribution of electrons in atom equal to the atomic number and equal to the number of protons that have a positive charge, and also equal to the number of electrons that have a negative charge. So in the periodic table, if we need to make distribution of electrons in atom, we have atomic number for hydrogen equal 1. So the number of protons equal 1, equal to the number of electrons that equal also 1. So we make distribution of electron equal 1 to this atom. In helium, another example for helium, we have 2, atomic number equal 2. So we make distribution of electrons equal to, it means that the number of protons equal 2 and the number of electrons equal 2. So the number of protons and electrons increased by 1 at a time and are always equal. So hydrogen atom 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6. This is increasing proton number and also increased by 1 at a time. And also the number of proton equal to the number of electrons. For example, in hydrogen, atomic number equal 1, the number of protons equal 1, and the number of electrons equal 1. Another example, nitrogen, atomic number equal 7, the number of protons equal 7, and the number of electrons equal 7. This is an atom. This is a nucleus, and these are electrons move around the nucleus and form shell. Electrons are arranged in shell around the nucleus. This is the first shell, this is the second shell, and this is the third shell. The first shell that is closest to the nucleus is the lowest energy level. The farther a shell is from the nucleus, the higher the energy level. In the periodic table, we can see hydrogen atom and we can know the period number. That is tell you about how many shells they are. Also, another example, carbon atom, sodium atom, and calcium atom. Also, if we need to know the group number, it's the same as the number of outer shell electrons. And these outer shell electrons are called valency electrons. This electron is called valency electron, and these 4 electrons are called valency electrons. This 1 electron is called valency electron, and these 2 electrons are called valency electrons. This is the outer shell electrons. This is the outer shell electrons. And this is the outer shell electrons, and also this is the outer shell electrons. If we need to know the period number, tell you how many shells there are. For hydrogen atom, there is a 1 shell only. So the period number equal 1. For carbon atom, there are 2 shells, so the period number equal 2. For sodium atom, there are 3 shells, so the period number equal 3. For calcium atom, there are 4 shells, so period number equal 4. In hydrogen atom, because of 1 shell, so it presents in period number 1. Here, period number 1, we find hydrogen. In carbon atom, we have 2 shells, so carbon present in period number 2. Here, period number 1. Here, period number 2. Carbon atom present in period number 2. Another example, sodium. Sodium atom present in period 3. There are 3 shells. We find sodium atom. This is period number 1, period number 2, period number 3. We find sodium in period number 3. Calcium atom. We find calcium atom in period number 1, 2, 3, 4. In period number 4. Here 1, 2, 3, 4. Calcium in period number 4, because calcium atom have 4 shells. 1, 2, 3, 4, 4 shells. The period number tell you how many shells there are. Okay, if we need to know the group number is the same of the number of outer shell electrons. Here 1 electron only, so present in group number 1. Hydrogen present in group number 1. Here the outer shell electrons or valence electrons are 4, so present in 4 electrons, so the group number equal 4. 1, 2, 3, 4. So carbon atom present in group number 4. Here sodium atom, in the outer shell electrons or valence electron, there is 1 electron only, so sodium atom present in group 1. Here sodium atom present in group 1. According to the number of outer shell electrons or valence electrons, calcium atom present in the outer shell 2 electrons, so calcium atom present in group 2. Here 1 and group 2, calcium atom present in group 2. So the number of valence electrons or outer shell electrons indicates to the group number, but the number of the shell indicates to the period number. Each shell can hold only a certain number of electrons. These are the rules. If we have argon atom, atomic number equal to 18, this is argon, and the distribution of electrons equal to 8,8. Here the nucleus, and here the electrons that move around the nucleus in shell. These are shells, 1, 2, 3 shells. The first shell can hold, this is the first shell, can hold only 2 electrons. It fills first. The second shell can hold 8 electrons. It fills next. The third shell can hold 18 electrons, but it fills up to 8. The next 2 go into the fourth shell. The distribution of electrons in the atom. Here argon atom with atomic number 18 and distribution of electrons 2,8,8 is written in a short way as 288 or 2,8,8 or 2.8.8. The scientist Bohr was the first person to put forward the idea of electron shells. There are some examples. The first example is sodium atom. Sodium atom has atomic number 11. So the distribution of electrons equal 11 because the atomic number equal to the number of protons equal to the number of electrons. We have 11 electrons. The first shell fill with 2 electrons and the second shell fill with 8 electrons according to the rules, and 8 plus 2 equal 10. So the remaining 1 electron in the third shell. So the distribution of electrons written as 2, 8, 1. Another example, chlorine atom. The atomic number equals 17. So 17 equal to the number of proton equal to the number of electrons. When we make distribution, the first shell fill with 2 electrons, the second shell fill with 8 electrons. 8 plus 2 equal 10. The remaining will be 7 electrons in the outer shell, the third shell. This is the valency electron, 7. So we write it as 2, 8, 7. All the elements in a group have the same number of electrons in their outer shell. So group 1 elements have 1 electron. Here, this is group number 1. Hydrogen atom, lithium atom, sodium atom, and potassium atom. Hydrogen atom has atomic number equal 1. So the distribution of electron to 1 electron. So in the first shell we have 1 electron. This is 1 electron in the first shell. So present 1 electron only. So present in group 1. Lithium atom has atomic number equal 3, which is equal to the number of electrons. We make distribution to 3 electrons. In the first shell 2 electron, in the second shell 1 electron. So the valence electron or the outer shell present 1 electron. Sodium atom has atomic number 11, equal to the number of electrons present in the atom. So we make distribution of 11 electrons, 2 in the first shell, 8 in the second shell, and 1 electron remaining in the outer shell, or valence electron equal 1. So present in group 1. The last example is potassium. Atomic number 19, equal to the number of electrons. So we make distribution of 19 electrons. In the first shell 2 electron, in the second 8, in the third shell 8, and in the last shell, fourth shell, equal 1. The remaining 1. So the group number equal 1 because the valence electron equal 1. Here 1 electron in the outer shell. Here 1 electron, 1 electron. So group 1 elements have 1 electron. Group 2 have 2 electrons. Here group 2, this is group 1 and this is group 2. Have 2 electrons in the outer shell. For example, beryllium, magnesium, calcium. Beryllium has atomic number 4. So the number of electrons equal 4. We make distribution of 4 electrons. The first shell 2 filled with 2 electrons. The second shell filled with 2 remaining. For magnesium, atomic number equal 12. And so it is equal to the number of electrons 12. You make distribution of 12 electrons. In the first shell 2 electrons, in the second shell 8 electrons, and the third shell 2 electrons. So the outer shell or valence electrons equal 2. in calcium atom, the atomic number equal 20. So we make distribution of 20 electrons. These 20 electrons in the first shell, 2 electrons in the second, and in the third shell are equal 8, 8, 2, 8, 8, and the last shell equal to 1. The fourth shell equal to 2 electrons. So group 2 have 2 electrons. Beryllium, magnesium, and calcium present in group 2 because they have 2 valency electron in the outermost shell.